In the videos of this lecture, we'll discuss the basics of optimization. We'll use linear programming as an example to illustrate the key concepts of optimization. In the latter part of this lecture, we'll go deep into linear programming. To that end, we'll introduce graphical approach to solving a simple linear programming problem. Then, demonstrate how to solve a linear programming model using solver adding in Excel. And then, discuss sensitivity analysis based on the sensitivity report generated from running solver. In the next lecture, we'll emphasize the applications of linear programming and advanced modeling skills for linear programming. All optimization models have several common elements in addition to inputs and outputs mentioned in Lecture 1. They are decision variables, objective function, and constraints. Decision variables are referred to as changing cells in Excel. They are the variables whose values the decision maker is allowed to choose. Objective function is referred to as the objective cell in Excel. An objective is to be optimized, either minimized, such as cost minimization, or maximized, such as profit maximization. The optimal value of objective function is often called the optimal objective value. Constraints are usually physical, logical, or economic restrictions depending on the nature of the problem. We'll see various types of constraints throughout this course. In any optimization problem, all the constraints must be satisfied. Optimization means that you must systematically choose the values of the decision variables to make the objective as large as possible in the case of maximization, or to make the objective as small as possible in the case of minimization, and make sure that all the constraints are satisfied in the meantime. Any set of values of the decision variables that satisfies all the constraints is called a feasible solution, and the set of all feasible solutions is called the feasible region. We'll demonstrate feasible solution and feasible region when we discuss the graphical approach to solving linear programming models. In contrast, an infeasible solution is a solution that violates one or more constraints. In optimizing our objective, infeasible solutions are not allowed. The desired feasible solution is the one that provides the best value for the objective, minimum for a minimization problem, and maximum for a maximization problem. This desired feasible solution is called the optimal solution. The optimal solution or solutions will generate the best or the optimal objective value. Next, we're going to turn to a simple linear programming example to demonstrate all these optimization concepts.